All right, fine. We start with the chapter solutions. In this chapter, what are we going to study? In this chapter, we are going to study the interaction of solute with a solvent. You understand the terms solute and solvent?
Yes, ma'am. Solute is the one in smaller component and solvent is the one in the bigger component.
Correct. Solute is one which is present in lesser amounts in a solution. Done? In this chapter, we are mainly focusing on binary solutions. What do you mean by a binary solution?
When there are two components only. So it's a salt solution, there's only salt plus water.
Very good. You are sharp. Chalo, you have the basic idea. That means it is one solute dissolved in a solvent. You do not have more than one solute and a solvent. Can you give me an example of a solution which has more than two or three components?
Um, a solution with more than, no, I don't know if I can give a great example.
All right. You've been to a beach.
Yeah.
The salt water, the sea water,
Mm-hmm. That's more than
the
two
sea water
solvents.
with
Solute.
solutes. N number of solutes will be present, plus you don't have only sodium chloride in it. All dissolved salts are present in it in trace
Mm-hmm.
amounts, different. All right. So seawater is an example of a solution which is having more than two components. What about air around you?
Hello, am I audible?
It's a
It
solution, right?
has nitrogen also. Yes, ma'am.
It has nitrogen, it has oxygen, it has hydrocarbons. If you are in a polluted place, it has got carbon dioxide,
Hello.
water, moisture. Depending upon the place you are in, it will have different components other than the major components, which is always there: hydrogen, oxygen, nitrogen, CO2. These are the components which will be there always. But there will be unburned hydrocarbons if I am near a refinery. There will be poisonous gases if I am near a refinery or a leather factory. Carbon dioxide, sulfur dioxide will be there. So these are having more than one or two solutes in a solvent. Agreed?
Yes, ma'am.
Okay. Now solutions can be of different types. I do not want to go there since I we just started the discussion. If I ask you an example of a solid solution and I ask you to find the example from these or choose from these an example of a solid solution: a sponge, a pumic stone, an alloy, which one would you choose as a solid solution?
So solid solution is when the solute and solvent are both solids, right? So
Correct.
if that's the case, I'll choose the alloy.
Very good. You will choose the alloy because here also you have air. Here also pumic stone will have air particles in the perforations, right? You understand what is a pumic stone, right?
Actually, no, that's a new
All right. You have
one.
seen the scrub or a stone-like thing which we used to your somebody in your house would be using to clean the toes, or if you have a pedicure done.
Oh, yeah, yeah, yes, ma'am.
The stone, yeah, that is a perforated stone, right? Which has
Yeah.
holes in it. So that
Mm-hmm.
is why I considered it as a solution because you have gas particles in a solid, right? So that's an
Okay,
example of
okay.
a pumic stone. Okay, that is pumic stone and having air in solid. Now, the solution, the chapter that we are studying, solution, has only one solute in a solvent, and throughout the chapter, B will represent the solute and A will represent the solvent.
Okay.
Okay,
Yeah.
now the first topic is ways to express concentration of solution. Since you are aiming for a competitive exam, I will be doing a little beyond the textbook. Okay.
Yes, ma'am.
Ways to express concentration of a solution. You are trying to find out how much of a solute is present in a solution. Can you list a few ways to express concentration of solution?
Concentration of solution. I'm not sure how to express it.
All right, no problem. Have you heard about mass percentage?
Oh, I've heard of it, but I forgot the term exactly.
It's all right. Mass percentage is you're finding out the percentage by weight of the solute in the weight of the solution. All right. So weight of the solute by total weight of the solution into 100. Done?
Okay. So like
If it is,
molarity comes here, is it?
no, these are not molarity. Molality, I'll come to it later.
Okay.
Volume percentage, these are basic
Volume of the
methods which
liquid
we
by
teach students.
volume. Yes, ma'am.
Correct. If I have mass by volume percentage, which is the most common form. So
Mm,
I'll have mass or weight of the solute by volume of the solution into 100, right?
yes, ma'am.
Agree? Now, have you heard the terms parts per million and parts per billion?
Yes, ma'am. Parts per million. I've heard of it.
Yeah. If these are the ways to express concentration when the solute is present in very, very less amount in a solvent. Okay?
Yes, ma'am.
So like in seawater, I'm trying to find out the percentage of salt or sodium chloride. I would use, instead of percentage, I would use parts per million.
Mm,
Or a solute which is still lesser, I would rather use parts per billion. Got it? Instead of
yes, ma'am.
percentage, we have just used this. Is this clear?
Yes, ma'am.
Now we come to grade 12, mole fraction. Actually, it is grade 11, mole fraction. How do I define mole fraction? Mole fraction is X. When I write B, it is the mole fraction of the solute. It
Mm,
is equal to the number of moles of the solute by the total number of moles present in solution. Okay? It is
yes,
a
ma'am.
fraction of number of moles of solute to the total number of moles in solution.
Yes, ma'am.
Written?
Oh,
Are we noting it down or we not noting it down?
yes, ma'am. I'm noting it down right now.
Shall I continue or I'll give you time to
One
write?
minute, ma'am. 1 minute. You just give
Okay.
me 2 minutes to write. Concentration. Ma'am, can you go a little bit to the left?
Yeah, I can.
Hello, ma'am. Can you hear me?
That's enough.
Yes, ma'am.
Hello. Hello, ma'am. Can you hear me?
Hi, please wait for 2 minutes. Ma'am will be joining back. 2 minutes.
Oh, sir, I saw in this
Done.
understood.
Yes, ma'am. I'm just noting down parts per million.
All right.
Yes, ma'am.
All right. Write a question and solve it. Calculate mole fraction of calculate mole fraction of ethylene glycol
Hello.
when
Am I audible?
5 grams of ethylene glycol is
Yes,
dissolved in
Okay. Adisha, could you turn on your camera?
90 grams of water.
Okay, that's nice. So, Adisha, I'll just quickly introduce about myself. Okay, so this is Shakti Priya, and like I've been doing math, physics, and coding
Yes, ma'am.
teaching more than. Hello,
So,
am I
okay,
audible?
Raj.
Yes, ma'am. Okay, all right.
How do we
Yeah,
go about
so
solving
I
this,
was
ma'am?
introducing myself. Okay, so I've been like doing physics, math, and coding teaching for like more than 9, 10 years now. Okay,
Ma'am?
and like I'm a engineer by profession, and for a greater part now I've like been associated with teaching as well, apart from my work otherwise. Okay, so that's about myself. So would you like to introduce yourself? You're not audible clearly. Have you connected to Wi-Fi or something like that?
Yes, ma'am. I thought. Can you hear me clearly now?
So number of moles. So we have to first, the carbon it is 12, the
Okay, the
mole,
formula
the,
to calculate. Yeah, I'm expanding the same formula, dear. Number of moles is weight by molar weight. Okay, so
yeah,
carbon is 12, hydrogen is 1, oxygen is 16. Now you can find it.
okay. So ethylene glycol is 31, right? Because we 12 and plus 3 plus 16 into 2, the whole into 2.
There are two carbon, no darling.
Yeah, yes, ma'am. The whole
CH2OH. So
CH,
won't it be 62? So there
oh,
should be two carbon, 24. Should be two oxygen, 32, and six hydrogen, right?
yeah, yeah. Oh, no, no, no. The thing is, I did the same thing, but I multiplied the entire thing into 2. So
All
I
right.
added the first
Okay,
one.
fine. Okay. Just check the substitution. I'll just check. Are you allowed to use calculators?
Yes, ma'am. For our exam, we are allowed to use. For our
All
boards,
right. Okay. So then it is
but
fine.
I'll
Yours is
not use
similar.
it.
Okay. So your substitution, just check the substitution. Your molecular mass came out to be 62.
Yes, ma'am. 62 and then 18 for H2. So it
Correct.
is 5 or 6.
The substitution stands like that.
Yeah.
So the rest is all calculator. So I'm not much bothered. If it was
Yes,
without
ma'am.
the calculator, I would have wanted to check your calculation skills. But then here it is a calculator. So next method of expressing concentration is molarity. Molarity denoted by capital M, the unit being moles per dm cube. So with the unit itself or moles per liters, with the unit itself, we can understand what should be the formula of molarity. Molarity is number of moles of the solute by volume of the solution in liters. What is number of moles? Number of moles is weight by molar weight into volume in liters. Conversion factor is what is written on top.
Yes,
All
ma'am.
right, because I'll convert the milliliters to liters.
What WB was given weight,
Weight in grams of the solute.
weight
Yeah,
in
given weight.
by molar weight.
Yes, by molar weight. Got it?
Yes, ma'am.
Now the question is, do you want other shortcut formulas which will be useful in competitive exams?
Yes, ma'am.
All right. Now I'm going to in detail give you the other formulas of molarity, but these are mainly shortcut formulas. To calculate molarity when density is given. To calculate molarity when density is given. So the formula is percentage into density into 10 by molar mass. Okay.
Yes. What is percentage here again?
I'll give you the question sample. The question is calculate molarity of 15% HNO3 solution having a density of 1.10 grams per cm cube. So the percentage is either weight by weight given or volume by volume, whatever is given. Suppose in general terms, if I say 15% weight by weight, means 15 grams of the solute dissolved in 85 grams of the solvent. Understood?
Yes, ma'am. Calculate. So 15% we will write it as 15 by 100, right?
No, you will just write
No.
it as percentage itself. I have not used it. This is a shortcut formula. Please remember. So everything as it is you are using.
Okay, so it will be m is equal to 15 into density is 1.1010
Yeah.
and into
Into
10 by HNO3. So that is, and nitrogen is
14.
it's 14. 14 plus 63
Correct.
by 63. Okay.
Yeah. Got done?
Yes, ma'am.
All right. For neutralization reaction or comparing the molarity of two solution, the formula used is M1V1 by N1 is equal to M2V2 by N2. So you can say neutralization or comparing molarities of two solutions. For example, if I say zero point 0.1 molar hydroxodium hydroxide is needed to neutralize 0.5 molar sulfuric acid in 100 ml. What volume of sodium hydroxide is needed? Now, the first thing that I'll do is I'll write an equation to check my stoichiometric coefficients. So my stoichiometric coefficient shows that the equation is 2 NaOH is reacting with 1 H2SO4. Is that part clear?
Yes, ma'am.
Now I assume that let NaOH be 1 and H2SO4 be 2. Okay. So M1 is given to me as 0.1. I do not know the volume. The N factor is 2 here. Here it is 0.5 into 100 by 1. Done? You understood how to apply the formula for this?
Yeah.
All
So
right.
we just
So you
take
can
the
write the,
coefficient of the compound. That is what the
yes,
denominator will be.
yes. N and N factor is the stoichiometric coefficient.
Yeah.
Got it? Write the formula and the example for you to understand where to apply it.
Yeah. 0.5 H2SO4 in 100.
Are we done?
Yes, ma'am. Oh, okay.
All
Yes, ma'am.
right. We'll go to the next formula, the last formula in molarity terms. Now, if I have got, suppose the case is, okay, this is used to find a resultant molarity, that is molarity on mixing. M is equal to M1 V1 plus M2 V2 by V1 plus V2. When do I use it? Suppose I have got 2 bottles of sulfuric acid kept in my chemistry lab and my lab attendant accidentally happens to mix it. Now I don't know the molarity or the concentration. So I will use this formula. It is the same thing mixed in the 2 bottles of the same compound. Understand that? Okay.
Okay.
For
Yeah.
example, if I say zero point 0.1 molar sulfuric acid in 100 ml is added to 0.2 molar sulfuric acid in 250 ml, what is the resultant molarity? So that is zero point 0.1 into 100 plus zero point 0.2 into 250 by 350, right?
Yeah. Yeah, I got it, ma'am.
You got it? How to apply the formula? I hope you copied the example so that you can use
Mm.
it later.
Yes, ma'am.
Now we come to the next term, next way of expressing concentration, molality, represented by small m. This is the unit of it is the unit is moles per kg. Now, molality is equal to number of moles of the solute by weight of the solvent in kgs. I expand the formula further. WB by MB into here it should be weight of the solvent. It is A. Weight of the solvent WA in kgs. Is there a confusion in the formula? Shall I write it again?
No, ma'am. It's MB into WA. Is it?
Down? Yeah, it is WA, weight of the solvent. Question is calculate the weight in grams of